Hey guys, okay, so I'm gonna go ahead and review today's lesson. So today's lesson was for 10/01/18. Okay, and so today's agenda was finding the rate of change, and then also finding out if an ordered pair does this satisfy the linear equation? Okay, so these are the two big ideas. There are two of these on the interim. Okay, one looks like this, fairly simple. Oops. Okay, one looks like this, and one looks like this, paying special attention to the fraction, okay? So there's one of these. Oops. And then there's one of these on the interim. Okay, there's two of these. Okay, two rate of change. All right, so let's go ahead and begin. All right. So we started with this idea. Okay, so the story here is, what is the weight of a winning dog at a dog show? Okay, so we have a dog show and we want to know what the rate of change, okay? So think of this, right? That means change. First of all, I know that this is y and that this is x. And if that's y and that's x, obviously it's changing, right? It's changing. But I want to know by how much. So this is going to be called the change of x, and this is going to be the change of y and change of x. Okay, so now specifically though, just looking at 2010 and 2011, that means these respectively. From 2010 to 2011, right, what was your change of x? 10 to 11, that's just 1 year. So you know the change of y over the change in x. So what was our change in x? Oh, it equaled 1. Okay, so what's our change in y, but only looking at these dates, right? Only looking at these years. So from 71 to 74, let's make sense of this. Okay, so we're talking about the weight of the dogs. We increased, right? Didn't we increase? By how much? By 3. And so this increase is what goes up here, because that's my change in y. And look, I want you to take notice of this. Notice, what does that look like? That looks like a slope. So now we know that the rate of change is the same thing as slope. They're the same. Okay, so anyways, all right, I think we're getting the point here. Let's go on to a next one. So Gordon's credit card changes. Okay, we're gonna look specifically at June and July. That's what we did in class. All right, so what's the change in x and what's the change in y? Well, we know that change in y goes on top. The change in y, because it's a rate over the change in x. Okay, so what is our change in x? From June to July, how many months is that? Well, it's just 1 month. Okay, so then from 61 to 61, what's the change? 0. Okay, so I hope somebody is asking, well, why? Why 0? Because there is no change. Okay, so how could I, as a mathematician, how could I show this? How could I show this no change? So here's what you do. You take your your second number and you're going to subtract your first number. Okay, so you take your second number, 61, take away, right? That's your last number. This is your first. So you take your last, take away your first. Okay, take away your first. And what was our first number? 61. And what's 61 minus 61? 0. So that's how you know, over 1, right? So that's how you know that it's 0. Because didn't we want to know the change, right? And change, that means find the difference. They're the same thing. So if I ask you, okay, so if I tell you, okay, last week I made $100 last week, but this week I only made 50. What's the change? What's the difference between last week 100 and this week I made 50? What's the difference? Oh, $50. It's the difference of $50. So the difference between 61 and 61, okay, again, the difference means subtract. The difference between the oldest and then the highest, or the first, is $0. There is no change. Okay, next one. All right, so I want to know the rate of change between Wednesday and Thursday. So I gotta go find Wednesday and Thursday. They don't want to know Monday and Tuesday as well. They don't want to know if there's a constant, right? They don't want to know a constant rate. They want to know just for those 2 days, what is the change? So from Wednesday to Thursday, that's a change in X. And then my change in Y. So here we go. Average food preparation time. We went from 49 minutes to 51. This is my last. This is my first. So 51 minus 49. Remember, I told you we have to take the difference. Remember, the difference means a change. So, and what's my change in X? Oh, I'm increasing by 1. Okay, so 51 minus 49. Right? Now, you can't take away from 1, so you got to borrow. So that's 4, and that's 11. And then 11 minus 9, 2. Oh, the change in Y is 2. Now be careful. 49 to 51, isn't that a difference of 2? Isn't it changing by 2? But be careful, it's increasing by 2. Okay, so this would be a good answer, or that would be a good answer. Okay? And then, of course, that's over 1, but we're not in a graph, so we don't really need that. Then we do division, so 2 divided by 1 is just 2. All right, rate of change for the wait time. Okay, so from the DMV, right, what happened between August and September? How did the change of wait time? So I want to know my Y. I want to know what the change in the wait time was. I don't really care about the month because we know it's going to be for 1 month. So in 1 month, what was the change in wait time? And if I want to know the change, I got to take my last and my first, right? So then you got to subtract 56 minus 43. Okay, well then over here, I got to do my 56 minus 43. 6 minus 3 is, 6 minus 3 is 3. 5 minus 4 is 1. Oh, it's 13. But be careful. Okay? Was that an increase or a decrease? Oh man, it increased by 13 minutes. Okay? 13 minutes is my change in wait time. So that's it. We got to find the difference between my last, take away my first, and then I found my difference, which is right here. Okay? Rate of change in wait time. So at the doctor's office, okay, there's my story. Here's my X, here's my Y. I need to find my change in wait time again. So my change in Y, just my change in Y, And I'm going to look at okay. This is my last, this is my first. So then we do 44 minus 31. And then we know that this is over a month, right? So that's my change in x, but I don't really need it. So then do my stacking. 4 minus 1 is 3. 4 minus 3 is 1. Oh, also 13. So there was an increase in 13 minutes. I think I chose the wrong date for one of these. I think I was supposed to do this one. Okay, so anyway, we're going to stop there. Okay, so for this one, 2016 to 2017, let's go ahead and do that one. I want to know my change in straight A students per the year. So this is X, this is Y. So my change in my students from 2016 to 17, that was 1 year. So it's going to be over a 1, right? Because my change in X is 1. All right, so what's my change there? Oh man, it's an increase again. So then we do 13 minus 5. Okay, so 13, 8, all over 1. So I increased by 8 students. And then what you guys aren't seeing here is I'm picking the dates. I'm picking when we're doing the change. Okay? Okay, this one. Okay, so somebody's about to come in and take out the trash. Okay, so for this one, it looks like I did 67, which is December, minus 71, which is, oh, nope, not even November, October. So how many months difference is that? That's 1, that's 2. So then that's why you put a 2 down here. And then you take the difference, 71 minus 67, okay? And again, be careful. It's over here, sorry.
Oh, okay.
Yeah, but I think it's empty because I don't think anybody knew it was there. Pay special attention to this. You got a negative 71 and then you got 67. Do you have more positives or do you have more negatives? And because you have more negatives, your answer should be negative. Okay, you're not done yet. So 4 divided by 2 is 2, but it's a negative. Okay? All right, guys, so that was that. That's what we did today, and we did a reflection. Okay, so the next thing that we're going to review is going to be ordered pairs. Does this ordered pair satisfy the linear equation? And there was a typo here. Y equals 8x plus 1. Okay, so y equals 8x plus 1. That was a typo. Does this point fit the line? So the concept, the idea, guys, the idea that I want you to imagine is if I have a line, is the point on the line? Is it part of my story? Does it fit the same rise and run as all my other ones, as of all my other points? Or if I have a line, is it not on the line? And that, oh my gosh, I'm not spelling right. That doesn't satisfy. Okay, so a point I hear, it doesn't satisfy my line. This one. But this one would. So here's what you do. If I take the point and I put it in the line, right? If I take my point and I put it in the line, I can tell if it satisfies, right? If it makes a true statement. So here I have an X and a Y. Okay, I should probably make this a little thinner. Okay, so I'm going to put my Y where y is. I'm going to put 25 right there. And instead of an x, I'm going to put a 3 right there. But that's kind of sloppy, so we're going to do this nice and neat. So if this is my x, and this is my y, okay, don't I need placeholders to put my sub, right? Because it's a substitution, so I put my 25 in there. And then I take my 3 and I put my 3, right? Multiply it by my 8. All right, and whatever you don't use, you drop. You don't use your parentheses. So on the next line, this is called simplifying. Simplify, you drop it down. So what's 8 times 3? 24. Can I simplify again? Sure. Drop this because you haven't used it or touched it. 24 plus 1 is 25. Okay? And because this equation says that this side equals that side, this side equals that side, that is a true statement. So you would say, therefore, 3, 25 does satisfy or fit or complete, right? Y equals 8x plus 1. It does. It fits. It's this point in there. All right, next. Caution. Be careful. Be careful. Be careful. Be careful. Be careful. I can't tell you enough. Okay, so now you have a fraction, but it's no big deal, guys. Just because you have a fraction, it doesn't mean it's difficult. So here's what you do. Same thing. You have an x. You have a y. Your x goes here. Your y goes here. Okay? That is called substitution. So, no matter what problem you do, y equals, placeholder equals 5 times your placeholder minus 3, right? No matter what you do, I did it again. For my substitution, I do placeholder equals 5 placeholder times my placeholder plus 1. Placeholder equals placeholder. Placeholder equals placeholder squared. You get the point? You're always going to do this substitution for step 1. Then, be careful. Right here, caution. You have a fraction. How are you going to multiply that fraction? Well, you need a fraction. So every number you put on top of a 1, 3, is the same thing as 3 over 1. Because what's 3 divided by 1? It's just 3. So it doesn't matter which way you write it. But because we need a fraction, we're going to put it on top of a 1. And then we're going to multiply. What's 2 times negative 3? Negative 6. What's 3 times 1? All over 3. And just because you have a fraction, it doesn't mean it's difficult. So now you remember, oh, that's just division. What's negative divided by a positive? Oh, it's negative 2. You're almost done. Again, caution here. Caution, integers. Integer, caution. Negative 2, you have 2 negatives, and you only have 1 positive. Do you have more positives or more negatives? Oh, you have more negatives. Then you subtract. 2 minus 1 is 1. Okay, I don't care if you have to do this. 1, 2, and 1 positive. That's a 0 pair. You only have 1 negative left. Again, I don't care what you have to do. All you have to do is make sure that you get the answer right. So, I don't know. Some of you guys learned a song. Same sign, add and keep. Different sign. Right here, different sign. Subtract. Keep the sign of the bigger number. Then you'll be exact. I don't know. So, yeah. That's what you do with fractions. So, if you have a fraction to start with, you have to remember to put it over a 1. And then you do your multiplication. Okay. And we forgot our left side. 1, 1, 1. Does 1 equal negative 1? No. So negative 3 comma 1 does not fit, but we're not going to say fit, we're going to say satisfy. The linear equation. Okay? All right, so if you want to practice, you can. These problems are basically the same. I'll have these answers on the board tomorrow. If this is x and this is y, that's 6. That's 3. Does 3 equal 6? No. So 3 comma 6 does not satisfy y equals x. Okay, same thing here. Just do your substitution. I'll do one more over here. There's my substitution. This is my x. This is my y. That's -1. Oops. This is my -3. Put it on top of a 1. Then I can multiply. Bring down everything. I didn't touch my -1. 2 times -3 is -6. 3 times 1 is 3 plus 1. -1 equals -2 plus 1. And -1 equals -1. Check. -1 equals -1. So -3 comma -1 does satisfy. Okay, again, don't forget, you put it on top of a 1 and then you multiply.